Okay, my name is Moosa Khan, and I've been teaching chemistry for past 12 years now. And I've been teaching chemistry in various schools and colleges across Pakistan. And recently, I've been teaching chemistry in Karachi and online as well. So I've been teaching O-level, IGCSE, Edexcel, A-level chemistries. So if you guys have any questions, you may ask. If you have any queries regarding your subject, feel free to ask. Then we will start off our session. Today, we will start from Unit 1 of Edexcel. Okay? Nothing. Should we begin now? So, first of all, you guys need to tell me if you guys can see both of my screens properly. We have one shared screen, and can you guys see my video? And am I audible to you or not? Okay, Sarah, I'm waiting for your reply. Okay, good. Okay, Ryan. Ryan, can you hear us? Can you see our screen as well? Please confirm so that we can begin. Okay, that's good. Okay, so first we have to start from the unit 1, that is International AS level unit 1. The topics that we need to cover in this unit are this: formula, equations, and amount of substance, commonly known as moles. In your previous grades, you must have studied this chapter with the names of moles and stoichiometry, but now we call it formula, equation, and amount of substance. The concept of mole is still same as that you studied in previous grades, but obviously the difficulty level is higher in this grade. Secondly, the topic we have is atomic structure and the periodic table. If you recall, the name of the topics are still similar, but obviously you have to go in greater depth of these concepts. Then we will study about bonding and structure, those topics that you must have studied with the name of ionic bonding, covalent bonding, and metallic bonding. And then finally, we have to study about the organic chemistry. And actually, it is the introduction to organic chemistry only in the unit 1. We will be covering only 2 hydrocarbons in this section, alkanes and alkenes. Right? So today we will begin our class from this topic, atomic structure. Why we aren't starting with the amount of substance or moles? Because once you have the proper knowledge of the chapter atomic structure, the structure of an atom, what elements are made up of, and what is the definition of element, mixture, and a compounds, and the difference between them, it becomes easier to solve the question for moles. So we will begin with the chapter atomic structure. And of course, I'll be asking you a few questions about like definition of an atom and an element so that we can see how we have to continue forward. Okay. So if I ask you guys, what is the definition of an atom? Or even before that, if I ask you, what do you think the whole universe is made of? You know, in first place, why do we need to study chemistry as a subject? Can anyone, listen to me. We need to make this session very interactive. So it cannot be just one-way communication. I expect you guys that you participate in the class. You can ask your queries, you can raise your hands, I can unmute you, and you can ask your queries on the chat as well. So if I ask you, why should you study chemistry? Why chemistry is important? Or if anyone can define chemistry, that would be wonderful. So what do you think? Why do we need to study chemistry as a subject? Why there is a need of it? Feel free to say anything because it's our first session and we want to embed into this subject. Chemistry is the study of structures. Okay, what about, okay, that's the right definition. See, if you're going to define chemistry right now, no definition would be a wrong definition. Chemistry is just a study of structures. It can be defined as the study of material. It can be defined as the study of chemicals as well. Chemistry is the understanding things we cannot see. Oh my God, that's a very good definition, and I like it. things that we cannot see. Okay, because we cannot see an atom. Why? Because it is very small. We cannot see it with a naked eye. Even we do not have a powerful enough microscope to zoom to that level that we can see an atom. Chemistry is the study of atoms and chemicals. Okay. Okay. If you want me to define chemistry for you, I would define chemistry as, if we see the course outline of our Edexcel chemistry, I would like to define chemistry is the study of chemical reactions. Of course, chemistry is also the study of chemicals, the structures, the materials, but our Edexcel chemistry revolves around the chemical reactions. So basically, we are trying to study chemistry because we got to know about the more detail of a chemical reaction, how different elements they react together, how they produce a new material. Because if you look around you, you can find chemistry everywhere. Because the food you eat, the water you drink, the medicines you need, the clothes you wear, chemistry is involved everywhere. Even if you just look around you, your entire universe, everything in the universe, apart from vacuum, everything in this whole universe is made up of a certain type of matter, right? The whole universe is made up of a matter. For example, us human beings are also a matter. We are made up of fats, proteins, and carbohydrates, minerals, and vitamins. Even non-living things, they are made up of matter. The air around you, it is made up of matter. If you see all the planets, they are made up of matter. So everything apart from vacuum, of course, vacuum is not a matter. Everything apart from vacuum is made up of matter. Can any one of you guys define a matter for me? What is a matter? How do you define matter? Matter is anything that has a mass and occupies a volume, right? Or occupies a space. Yes, matter is anything that occupies a space and that has a mass, right? And what is matter made of? Matter is made up of different elements. And elements are made up of atoms. So in order to understand everything around you, not just around you, but in order to understand everything in this universe, first you have to understand its basic structure, that is atoms. And where in which subject you're gonna go study about the atoms? It would be in chemistry. So this makes chemistry as one of the most important subjects, right? I'm not saying the only important subject, but one of the most important subjects, right? Okay, so how would you define an element? What is the definition of an element? Okay, the protocols of the class are, you guys feel free to ask in the chat. If you want me to unmute your mic, you can raise your hands. I will unmute your mic. And secondly, you should have a notebook with you to make notes. And I would suggest from the next class, you should carry a calculator with you, a scientific one, so that if we need to solve anything, you should be able to do it as quickly as possible. I will send you the periodic table that is given into the specification of Edexcel chemistry. I would suggest you take a print out of it and keep it on your table. Yes, element is made up of different type of atoms. Okay. An element is made up of same type of atoms. We have got two definition of element. Group of atoms of the same kind. Yes, Sarah, that's very good. Made up of different bondings. Okay, let me define element for you. You have almost told me correctly, but the proper definition of an element is a pure substance. An element is a pure substance that is made up of same type of atoms only. Can you guys give me example of any element of your own choice? An element is a pure substance. The word pure substance is very important. And the second key word is it is made up of same type of atoms only. For example, if we are dealing with carbon element is made up of many carbon atoms. If we have many carbon atoms in one place, that would make up your carbon element. If you have many hydrogen atoms in one place, that would make up your hydrogen element. If you have many oxygen atoms in one place, that would make up your oxygen element. So same type of atoms, when are grouped together, they make a certain type of an element. Let's say if we talk about gold element, a gold element is made up of many gold atoms. Similarly, a silver element is made up of many silver atoms. So when we have same type of atoms grouped together, they make a certain type of an element. So a gold element is made up of many gold atoms. And what else? Hydrogen element is made up of many hydrogen atoms. Right? And how do you write? How do you represent atom of any element? You represent atom of any element with the symbol. And these symbols are known as chemical symbols. For example, for carbon, the chemical symbol is capital C. For gold, chemical symbol is capital A and small u. Always remember, whenever we are writing the two-lettered symbol, first letter should always be a capital letter and the second letter should always be a small letter. Similarly, if we have to write a one-lettered symbol like carbon, the first letter should be a capital letter. Got it? For example, if you have to write a symbol for chlorine element, it has a two-lettered symbol. The first letter should always be a capital letter and the second letter should be a small letter. Got it? Okay. Now, my question from you is that every element is made up of an atom, right? Gold element is made up of many gold atoms. Carbon element is made up of many carbon atoms. But still, gold has different properties. Carbon has different properties. You guys know what gold is. Gold is a metal. Gold can be used as a jewelry. Gold can be used as a good conductor of electricity. Gold is very expensive. Whereas carbon is, you know what carbon is? We have two allotropic forms of carbon, the diamond and the graphite. The graphite is the pencil lead. So carbon is dull, carbon is gray, carbon is a non-metal, and carbon is very cheap. Although both gold and carbon, they are made up of atoms, but there must be something different between the atoms of carbon and atoms of gold. That's why the properties of gold are way different than the properties of carbon. So what is the difference between the properties of gold and properties of carbon? You guys must know. But what is the difference between their atoms? Every element is made up of atoms. Atoms must have some common features, like every atom of every element is made up of three types of subatomic particles. Can you name them? See, what I'm trying to explain is every element is made up of atoms, but still they are very different. How come they are different? Because it means that there must be something different between their atoms. Although all the atoms of all the elements are made up of only three types of particles: protons, neutrons, and electrons. So what is the different about them? The difference is the quantity of protons, neutrons, and electrons is different between different atoms. A carbon atom has 6 protons, a gold atom has 79 protons. So the number of protons, neutrons, and electrons are different between the atoms of these elements, and that make their properties different. That's it. So how do you define an atom? First, because we have to study the difference between the properties of these elements, it means first we have to understand the structure of an atom and the difference between these atoms. So first we have to define an atom before start studying the structure of an atom. So how would you define an atom? Yes, Nida. Would you define an atom for me? An atom is the smallest unit of structure. Okay. What else? Well, let me tell you. An atom is the smallest particle of an element that takes part in a chemical reaction. An atom is the smallest particle of an element, right? You guys already know what an element is. So every element is made up of atoms. An atom is the smallest particle of an element that takes part in a chemical reaction. The word chemical reaction is very important over here because you guys must have already understood what element is. But in order to understand the chemical reaction, you guys may have taken you guys more than 2 years to understand what chemical reactions are, because when you studied the complete chemistry in your previous grades, you guys must have realized how chemical reaction happens, why chemical reaction happens. So if any element has to react with each other, their atom has to react with each other. Yes, Siddha, you want me to open your mic? Rida, you're asking some question? Yes, very good. Rida is saying an atom is not technically the smallest unit because atom is in fact made up of different types of protons, neutrons, and electrons. If you see an element, we have an atom, and inside the atom, we have protons, neutrons, and electrons. So how come we are saying that atom is the smallest particle of an element? See, let me explain it to you why. Because if let's say if we have a carbon element is made up of many carbon atoms, right? And until or unless its nucleus has 6 protons, we will keep calling it a carbon element. If any atom has a nucleus with 6 protons, it is known as a carbon element, right? So if the nucleus of any atom has 6 protons, it is a carbon element. If you just remove the one of the protons from its nucleus, will it still be called a carbon atom? No, it will become a nitrogen atom. So because if you're gonna define an element's identification, it's atomic number. Because if we keep on dividing an atom, if we keep on dividing an element, let's say if we have many carbon atoms in one place, and if we keep on dividing these carbon atoms, for example, if we divide this carbon element and we have 2 carbon atoms on the left hand side and 2 carbon atoms on the right hand side, still we would call it carbon element. Let's say if I have a pencil in my hand, it is made up of carbon. If I just break this pencil into 2 halves, both the halves would be called as a carbon element. If I keep on breaking the pencil into different and smaller and smaller and smaller pieces until I reaches single atom, I mean, if I keep on dividing it and until I just have a single atom, still it would be called as a carbon element because this single atom is also representing the carbon element. But if I just divide this carbon atom, if I just divide the nucleus of a carbon atom, its number of protons are divided. Once its number of protons are divided, the 2 pieces of this atom wouldn't be called as a carbon atom because identification of a carbon element is that its nucleus must have 6 protons. So if you have to define an element, we have to define it like it is the smallest particle of an element. Because if we go further beyond the nucleus and if we divide the nucleus, then we can no more call it a carbon atom. You got my point? So if we just collectively sum up everything, we can say that yes, atoms are in turn made up of protons, neutrons, and electrons. But if we divide, if we separate their protons, we cannot call it a particular type of element. Okay. Anybody else need to ask anything? The more questions you're gonna ask, the clearer the concept you will get. So I highly recommend you guys to keep asking anything that you feel is unclear. Okay. So next, we should know about the structure of an atom. Every atom is made up of. Atom of every element is made up of only three types of particles, which are known as subatomic particles. Within an atom, we have three particles, which are known as subatomic particles, and you guys know it very well. These are protons, neutrons, and electrons. Protons and neutrons are clumped together at the center of an atom, which is known as the nucleus of an atom. And the electrons, they revolve around the nucleus, right? For now, you can imagine protons, neutrons, and electrons as tiny little balls. Let's say a proton are blue colored balls, and our neutrons are red colored balls, and our electrons are black colored balls, but they are very small in front of protons, neutrons, and electrons. So protons and neutrons, they are basically stick together at the center of an atom, which is known as the nucleus of an atom. This is known as the nucleus of an atom. And the electrons, they revolve around the nucleus into their energy shells. That's what you used to study in previous grades. But now we will go into further detail. We won't go into the more detail of nucleus, but as for energy shells, we will be dividing energy shells into principal quantum shells, subshells, and then orbitals. So we will shortly come to that. But for now, I want you to ask, do you guys know the relative mass of protons? Do you guys have any idea about the mass of protons, neutrons, and electrons? We have three types of subatomic particles, and you are supposed to know about the masses of protons, neutrons, and electrons. So can anyone tell me the mass of protons, neutrons, and electrons? Okay, Sarah, you are telling me the charges of protons, neutrons, and electrons. I'm asking you about the mass of protons, neutrons, and electrons. You think it's 1862? Whenever you have to state any quantity, you have to tell me the unit with it. What is the unit for mass? What is the SI unit for mass? It's grams. So if you are telling me the mass, you have to put a unit of mass with it. Okay. Okay, kilograms. Okay. So what is the mass of protons? Any idea? 1 gram for proton. Oh, do you know what how much 1 gram is? Oh yes, Sarah, you can use the atomic mass unit. We can also use grams or kilograms. But I'm more interested in the mass of protons, not the mass of any element. Electron is one, the value of the protons. Okay, Rida, you are getting to something. Basically, in your previous grades, you were never told about the mass of protons, neutrons, and electrons. Let me tell you this. It's very interesting because we were never told about the mass of protons, neutrons, and electrons. Even in this grade, we won't be discussing the mass of protons, neutrons, and electrons. We were never told about the mass of protons, neutrons, and electrons. Never we were told about the charges of protons, neutrons, and electrons. We were always told about their relative masses and the relative charges. Do you guys know what is the difference between the actual mass and the relative mass? Yes, if you are saying the mass of proton is 1 gram, 1 gram is a very appreciable amount. You can see 1 gram of a substance with your naked eye. If I asked you to just get a pinch of salt, a pinch of salt would weigh near about 1 gram. So do you think a pinch of salt is equals to 1 proton? A pinch of salt would contain millions and millions of atoms of that particular element. And you can imagine how many number of protons would be there. So 1 gram can never be the mass of 1 proton. Relative mass is the mass if the atom's mass, okay? Okay, let me tell you. You are not supposed to remember that, but you should have the idea that we have to remember the relative masses, not the actual masses. But of course, you should know the term what relative mass means. Relative mass is not the actual mass. Let me give you an example of it. For example, if we have a mass balance, and on this mass balance, let's say I am standing on this mass balance and I weigh around 80 kilograms. My mass is 80 kgs. Now see, I am using the unit for mass, that is kilograms, right? Let me make my more interesting. And let's say if Rayan is also standing with me on this mass balance and Rayan's have spikes. I am assuming Rayan's hairstyle is spikes. Rayan's weigh 40 kg. So one of my student Rayan, he weighs 40 kg and I weigh 80 kg. So my mass is 80 kg and Rayan's mass is 40 kg. This is our absolute or actual masses. But if I take the simplest ratio between our masses, how would I take the simplest ratio? We'll just divide these two numbers by 40 because we have to divide by the common number. The largest common number between 80 and 40 would be 40. Do you guys know what simplest ratio is? If we divide these two numbers by 40, we would get 2:1. This is the ratio between my mass and Rayan's mass. This is the ratio between my mass and Rayan's mass. That ratio can be called as relative mass. For example, if I hide our actual masses and if I say I am my mass and Rayan's mass ratio is 2:1. So you guys can say that Sir Moosa is twice heavier than Rayan. If I weigh 80 kg, Rayan must weigh 40 kg. If someday I weigh 100 kg, Rayan must weigh how much kg? 50 kg. If I someday weigh 200 kg, Ayan would weigh 100 kg. Oh my God. But that won't happen. Just an example. So this is the ratio between our masses. Similarly, we have never told you about the actual mass of protons, neutrons, and electrons. Nor we will going to tell you in this section. But just to give you an idea, you should be curious about it. You know what mass of proton is? Mass of proton is around 1.67 into 10 raised to the power minus 27 kilogram. That's a very, very, very small value. Even if you just calculate it in grams, it should be equals to 0.000000000 around 29 zeros and then 167. This is really very small. Similarly, if I tell you the mass of neutron is exactly similar to the mass of protons. And what about mass of electrons? Mass of electron is 9.11 exponent minus 31 kilogram. If I take the simplest ratio between the masses of protons, neutrons, and electrons by dividing all these masses by the mass of proton, neutron, and electron, I will get the ratio between the masses of protons, neutrons, and electrons. Of course, you are not supposed to remember these masses. I'm just telling you for your understanding. But if you take the simplest ratio between these masses, the ratio between the mass of protons and neutrons should be 1:1 because they have the equal mass, whereas electrons are about 2000 times lighter than that of the protons and the neutrons. So the ratio between the mass of electron would be equals to 1/1836. You're not supposed to write, remember these values. I'm just telling you, okay, what does the relative mass comes from? So relative mass is the ratio between the masses. It just tells you how heavier the protons, neutrons, and electrons are from each other. Protons and neutrons have an equal mass. That's why the ratio between their masses or the relative masses is 1:1. Whereas electrons are about 2000 times lighter than that of the protons and the neutrons. This value 1/1836, we can just remember this value as, if we round it off to three significant figure, we can just remember it as 2000. It's acceptable if you want to write 1/2000. Even if you want to write 1/1836, that's acceptable too. But of course, we will go remembering the easier values. Even in fact, if you want to write it in the decimal form 0.0005, that would also be acceptable. So We just have to remember the relative masses of protons, neutrons, and electrons, but not the actual masses. You should just have an idea what is the meaning of the relative mass, and that's it. So protons and neutrons are equally heavier, and the ratio between the masses of protons and neutrons or their relative mass is 1:1. Whereas electrons' relative mass is 1 over 2000. Yes. You got my point now, Aisha, Nida, Rayan, Rida, and Sarah. Do you guys have any queries regarding this? Okay, great. Now, about the charges. Do you guys know the unit for charge? What is the unit for charge? The charge, basically you study about the charge in physics. And the unit for charge is coulombs. Again, I'm not going to tell you the actual charge of protons and electrons. The relative charge is the ratio between the charges of protons and electrons. If I just to give you an idea, I think in your previous grades in physics, you must have studied about the charge of electron. Charge of electron is 1.6 into 10 raised to the power minus 19 coulombs. And the polarity is negative. Similarly, the charge of proton is exactly same to that of the charge of electron, but its polarity is positive. So if we take the ratio between the charges of protons and electrons, it should be 1:1. The only difference between the charges of protons and electrons, protons are positively charged and electrons are negatively charged. And neutrons, they do not have any charge. So we say that neutrons have a neutral charge or a zero charge. We can also call it a neutral charge. Got it? So we are just supposed to remember the relative masses and the relative charges. But at the back of the mind, because you are studying chemistry and you should know what does a term specifically means. Relative mass and relative charge are not the actual charges of or the actual masses of protons, neutrons, and electrons. This is just a comparison between the masses and the charges of these subatomic particles. You got the idea? Anything so far so good? Anything you guys need to ask? All clear. Should we move forward now? Okay. So protons and neutrons, they are present at the center of an atom. And we call it a nucleus of an atom. And we do not have to discuss a lot about nucleus, what does protons are doing into the nucleus, how they are protons and neutrons are staying into the nucleus. By the way, I have an assignment question for you guys. This is a fun something that you need to braining. This is not like assignment something, but let me just ask it to you and you guys have to search about it because Bacho, you have to realize one thing that you are studying science and science is very interesting. And you should try to process or comprehend concept. Like I think a while ago, someone asked me why we are saying atom is the smallest particle of an element, when in fact within an atom we have different types of subatomic particles. So I need you guys to process your mind like this. You have to ask question. Whatever comes up in your mind, you should ask the question. See, do you guys know anything about the law of charges? Positive charges, they repel each other, and positive and negative charges, they attract each other, right? Means I like charges, two positive charges or two negative charges, they will always repel each other. A positive and a negative charge, they will always attract each other. Two negative charges, they will always repel each other, right? If we see a nucleus of any atom, it has protons which are positively charged, it has neutrons which does not have any charge. But there are many number of protons staying inside the nucleus of an atom. They must be repelling each other and they should be coming out of the nucleus. But despite being same charge, they still stay in the nucleus at the same time. How? This is the question. I just need you to process and you can search it over the internet and you have to make your own answer. Okay, by searching it. This is the question the examiner won't ask you in the exam. This is something out of the box that you guys need to think. I'm saying is protons and neutrons, they both stay into the nucleus. Neutrons, they do not have any charge. Protons, they both have positive charges, but all the protons in the nucleus must have a positive charge, and positive charges, they repel each other. But still, despite being same charge, all the protons, they stay into the nucleus at the same time. Why they are not repelling each other and coming out of the nucleus? Electrons, they are revolving around the nucleus. Electrons are not present in the nucleus, right? How come protons, despite being positively charged, they are staying into the nucleus? They should be repelling each other. I'm leaving this question for you. You have to find it for yourselves. This is not the part of our syllabus actually, but it's just something that you guys should process. I want you guys to think in a way that everything that does not make sense, you should be able to answer it. You should be able to question it at least. Yes, Rida, you are onto something. Okay, but we are just leaving this question here, and you guys have to do it by yourself. If you want to do, otherwise it is not mandatory, because he won't be asking you this question in exam. So now coming back towards the topic, I was trying to say is, yes. So now we know in the atom, protons and neutrons, they are clumped together at the center of an atom, which is known as the nucleus of an atom. And we won't discuss anything in more detail about the nucleus of an atom, because the nucleus, you guys have to deal into the subject physics. But as far as the electrons are concerned, electrons is the domain of chemistry. We will be studying a greater depth about electrons. So in previous grades, we used to study that, let's say if we see an atom of any element like sodium element has a symbol Na. Every element is represented by its symbol. If you see the periodic table, let me just get the periodic table for you guys. Do you guys have periodic table right in front of you? Wait, let me just open the periodic table for you and then I'll show you. You guys must have seen the periodic tables. Okay, periodic table has different, how many elements are there in the periodic table, by the way? How many elements we have discovered so far? So far, we have discovered around 118 elements. And each element is represented by its single atom into the periodic table. Only one atom is enough to study about the atom of that particular element. If you have studied about the atom of one element, it means you have studied about its atom throughout the world. So in the periodic table, if you see the periodic table, each element is represented by its symbol, and with the symbol they give you two numbers. One number is written at the top of the symbol and the other number is written at the bottom of the symbol. What does these two symbols represent? These two numbers gives you the number of protons, neutrons, and electrons. How would you know about the number of protons, neutrons, and electrons in the atom of any element? Because if you want to study about the atom, you just need to know about its number of protons, neutrons, and electrons, and that is more than enough in order to understand any atom. Let me see, this is the data booklet that is given our spec, and at the end of it, you will find the periodic table. I will send this file to you guys. I would recommend that you should take a printout of the periodic table and you keep it always with you. See, there is a periodic table right in front of me. What I have done is I have taken the printout of this periodic table. I have laminated it and it stays on my table. Because I am a chemistry teacher, because I always need a periodic table. And when you are studying a chemistry subject, so you should have a periodic table with you. Anyways, right now, if you can just see this atom sodium. Sodium has a symbol Na. I am sorry for this orientation, but I hope you guys can understand. Sodium has a symbol Na, and we have two numbers written with the sodium. One number is written at the bottom. The number written at the bottom of any element is known as atomic number, or this is also known as proton number. And the number written at the top of the symbol is known as relative atomic mass. So first we have to discuss what does these two numbers represent, And if you guys already know, you should answer. Meanwhile, if you guys know about it, I would highly appreciate if you just start telling me. With every element, they have written the name of that element, and at the bottom, they have written one number, and at the top, they have written one number. The number written at the top of the symbol, they have given it as a name of relative atomic mass. But this number has two more names. Can you tell me what are those two other names? This number has two more names. One name is its mass number. The other name is its nucleon number. Very good. You guys already know it. And the number written at the bottom is known as atomic number. Atomic number has one more name. This is also known as proton number. Okay, great. So what does atomic number tells us? Atomic number or proton number actually tells us about the number of protons present in the nucleus of an atom. Every atom of every element is made up of three types of subatomic particles: protons, neutrons, and electrons. And we need to count the number of protons, neutrons, and electrons that are present with every atom. We have to count it, because if you know about the number of protons, neutrons, and electrons, it means you know everything about that particular atom. So atomic number tells us about the number of protons. It tells us about the number of protons in the nucleus of an atom, right? And the second point is, it also tells us about the number of electrons present in the atom. Tells us about number of electrons present in an atom. The number of protons and electrons in atom are equal. For example, if sodium has an atomic number of 11, it means a sodium atom has 11 number of protons as well as 11 number of electrons. A sodium atom has 11 protons and 11 electrons. Every atom is made up of only three types of subatomic particles. You know the number of protons and electrons. You are just left with the number of neutrons. How do you find the number of neutrons? Yes, if right now I am talking about atom. Atom means there is no charge, right? If any atom loses or gain electron, it gets a charge, a positive charge or a negative charge. Then I won't call it an atom. I would call it an ion, right? A cation or an anion. But if I'm saying about atom, an atom must have equal number of protons and electrons. The number of protons are always equal to number of electrons. So this one number, atomic number, it does not tells you about the number of protons, but it also tells you about the number of electrons. Now you are left with number of neutrons only. So the other number that is written at the top of the symbol is termed as mass number. In this chapter, we will be dealing its name with mass number or nucleon number. Otherwise, when we are going to study the chapter moles, amount of substance, we would call this number as relative atomic mass as well. So for now, if I ask you what does mass number or nucleon number represents, it tells you about the sum of protons and neutrons that are present in the nucleus of an atom. Mass number or atomic number tells you about the sum of protons and neutrons present in the nucleus of an atom, right? So the nucleon number for sodium, if I write it mathematically, it should be nucleon number is equals to protons plus neutrons. So for sodium, its nucleon number is 23. See, it is nucleon number with L. The common mistake that we do is, if he asks us to write the nucleon number, we go on writing about the neutron number. See, neutron is different and nucleon is different. Here on the right hand side, we have neutron that comes with TR. And on the left hand side, we have nucleon. It has CLEON. So these two are different names. Most of the students, they confuse with these two names, but these two are different names. If he asks you about the nucleon number of an atom, that is directly the number of nucleons or the atomic mass that is given in the periodic table. And what about number of protons? Number of protons in a sodium atom is 11. And how would you find number of neutrons? You just have to subtract the atomic number from its mass number or nucleon number. 23 minus 11 would give you the number of neutrons in the nucleus of an atom. So that's how you find the number of protons, neutrons, and electrons in every atom of all the elements. You just have to know its atomic number. It would tell you about the number of protons and number of electrons. And how do you find the number of neutrons? You have to subtract these two numbers. You have to subtract the atomic number from the nucleon number. That's it. And you will get the number of neutrons. Protons and neutrons, we know that they are present in the nucleus of an atom. But what about electrons? Electrons, they are revolving around the nucleus. And they are revolving around the nucleus in energy shells, right? What you used to study in previous classes about the electrons? What do you guys already know about the electrons and how do they revolve around the nucleus? Do you guys have any idea about electronic configuration? Okay, they orbit around the nucleus. Yes. What else? What else do you know? Rayan, Aisha, Rida, Sara. I just need to know, okay, what else you already know about it. First shell consists of 2 electrons. Very good. What else? Second shell consists of 8 electrons. We used to study first shell cannot hold more than 2 electrons. A second shell cannot hold more than 8 electrons. There can be 8 electrons or there can be less than 8 electrons, but no more than 8 electrons. Yes, you need to fill the shell completely before moving on to the next shell. Very good. So electrons, they basically revolve around the nucleus in fixed paths, and these paths you used to call them energy shells, right? Or sometimes you just used to call them shells. But now here in this grade, in Edexcel-Alevels Chemistry Unit 1, we would be calling them quantum shells. Their actual name is principal quantum shells, but as far as our syllabus is concerned, we would just call them quantum shells. Now we won't call them shells, we will call them quantum shell. It has a full name. Its full name is quantum shells. And within those quantum shells, we have actually, previously we just used to study that electrons, they are present around the nucleus in shells or quantum shells, right? But we have spaces around the quantum shells as well. Those are known as subshells. We have to go in more detail now. For example, if I ask you, let's say if I ask Nida, can you tell me your location? Where do you live? And if you just tell me, where do you live, by the way? Dubai. Okay. If Nida just told me she lives in Dubai, and if I have to find Nida Khan in Dubai, would it be possible for me to just locate Nida if I just know that she lives in Dubai? It's certainly impossible. And that's what we used to do with you guys back in previous grades. We just have told you the electrons are first shell electrons are present in its shell. That's it. We need to specify the more exact position of electron. Now, if I need to find Nida, where do you live in Dubai? Any area? Nada. Okay. Now, is it easier for me to find her in her area? But if she tells me her house number as well, then I can specifically reach to her. So if you need to find the location of someone, you have to tell me their country, their area, the city, their area, and their house number. That's how I can reach a particular person. Similarly, now what we're going to do is we have to see within the quantum shells, there are subshells present. So electrons are there in the quantum shells, I know, but within the quantum shells, there are subshells. And within those subshells, we have orbitals. So just like there is Dubai, and in Dubai, there is a city, Nada, or area, Nada, and in this particular area, she has a specific house number. Similarly, in order to know more about the electrons, we need to know about their more specific location. I know first shell electrons are present in their first quantum shell. Within those quantum shells, we have different areas which are known as subshells. And within those subshells, we have further specified different areas which are known as orbitals. So we will go on studying about orbitals first, and then we will see how orbitals are present in the subshells, and then we will see how subshells are present in their quantum shells. So first, what is orbital? Orbitals are basically the regions or the areas where chances of finding the electrons are maximum. Let me define it to you. Orbitals are the regions around the nucleus where chances of finding the electrons are maximum. Got it? So we will keep it up till here. Now we are actually entering about the location of electrons. So it will get bit difficult from here. In today's class, we tried to just take an overview of everything. And of course, as per our syllabus requirement, we have to go in further depth. And I will discuss with you guys about the books, the resources, the past paper questions in coming classes. I will send this PDF to Sir Hamza. He will upload it on your portals, and every other resources that we need to study for this course, we will upload it everything on the portal. Got it? Okay. If you guys have any questions you need to ask, feel free to ask, and we will try. We have planned to end this course in mid of December before your exams. Of course, maybe before mid of December, first week of December. And about past papers, we will keep doing past paper with every topic. And in the end, we will do complete past paper questions so that we get well prepared for this course. Okay, if you guys have any question, you may feel free to ask. If you have nothing to ask, you guys may leave. Thank you so much. Allah Hafiz.